between the blood and exhaled CO2. So, if you draw blood gas and the PaCO2 is 40 millimeters of mercury, what would be a normal exhaled CO2 for that person? 35? 35. 5 millimeters of mercury lower. So, PaCO2 40, EtCO2 35. And what if you have a COPD patient? You've got obstructed airways. Would you expect more of a difference than 5? They've got obstructed airways?
Because they're retaining it.
Yeah, their airways are obstructed, so it's hard for them to get that CO2 from the alveoli to the atmosphere. So there's a bigger difference in the CO2 between the blood and what they exhale. So a CO2 retainer, let's say they have a PCO2 of 60. What would you expect for their exhaled CO2? 55? 50? 45? Yeah, about 10 torr less than what's in the blood, depending on how bad their disease is. So that's an average.
And that's what obstructed airways.
With obstructed airways, about 10 torr lower than the blood. Dead space to tidal volume, we've talked about that before. You want your tidal volumes on your patient to be large enough so that they're just not moving the dead space in and out of their conducting airways. So dead space to tidal volume should be, what did I say, 30% or less, or is that what I told you? I gave you guys numbers, and every time I try to remember it. So what's good? Less dead space to tidal volume, right? So if you have typically a 150-pound person has 150 mLs of dead space, and a 150-pound person would have a tidal volume of about 400 ml. So it's about 30%, 37%. So as the number gets higher, there's less tidal volume to dead space. We do this a lot. We compare the minute volume to the CO2 and the blood gas. So if the minute volume is, didn't you guys already see this question somewhere? You found a review for the last test and it had that question on there. Patient has a minute volume of 15 liters. And they're breathing fast. Respiratory rate is 30 and moving 500 ml tidal volumes. And this is sustained. And then you get a blood gas and you see that the CO2 is 40. How can the CO2 be 40 if they're moving 15 liters of air in and out of their lungs every minute?
VQ mismatch?
Yes, a lot of VQ mismatch going on in the lungs. I don't think we're getting to our other handout today. What does a capnogram display? It looks a little busy. Let me just cover a couple things here. So when you breathe in, I'm going to go too fast. Let me slow down. So when you breathe in, you're breathing in room air. And in room air, there's almost zero carbon dioxide. So what that will do to the capnometer reading is bring it down to baseline. So as you're breathing in, you'll see 0. Then, as you blow out, there's carbon dioxide from your lungs that you're blowing out. So you'll see the graph starting to go up as the CO2 is coming out. Then, when you're exhaling the part from your alveoli that's coming out last, you'll see it start to plateau and stays the same. And at the very end of your exhalation is where you'll get, or the machine does it actually, it'll take the reading of the carbon dioxide at the end of exhalation, because that's going to be the air from the alveoli that have emptied. That's what empties last. So that's where you get your end tidal, meaning the end of your tidal volume. is where you get your CO2 reading. So if you have problems with ventilation and perfusion, you're not going to have as much exhaled CO2. Where's our COPD patient? Oh, over here. So left heart failure or COPD patient, it takes them a while to get the air from their alveoli exhaled. So their graph will climb more slowly and take a lot longer. That's all. And then comparing exhaled CO2 to arterial blood, there's an equation. So it tells you that the CO2 and exhaled air should be almost equal to that in the blood. So PaCO2 is arterial blood level of carbon dioxide, and PEtCO2 is exhaled carbon dioxide. So the capnometer reading is actually 4 to 6 millimeters mercury lower than the CO2 in the blood, and this is normal. Okay, we already talked about the reading. If you see this on an exam where you see all these spikes going up and down, it's just because they change the speed. So this is like a minute's time. This one breath is just like a couple seconds of time. So you'll be able to recognize that if you see it again? This is just a lot of breaths, and this is looking at one breath more slowly. And then troubleshooting your graphs. No, I don't see anything here that you need to apply for the test, just this top one. So when the patient's exhaling, you should see CO2 rising steadily. Why would you see a dip and then some more coming out? And it's just the way that the airways are emptying. So you would suspect obstructed airways when you don't see a good waveform. And I think that's about it. This looks like there's air being introduced into the circuit somehow. And that's really all you need to know. How often do you see Untitled CO2 used? It's used with spontaneously breathing patients because during conscious sedation, you can put a nasal cannula on, and part of that nasal cannula will connect to the Untitled CO2 monitor. And if that sedation has over-sedated the patient, and they're hypoventilating or they've stopped breathing, now you've got a machine alarming that's more sensitive than just looking at your O2 stats. So it's becoming, I'm so happy to see this, because that was my greatest fear, is ever going in for a procedure and have them not notice that I'm over-sedated and not breathing, and then wake up and you wonder why you don't remember your name anymore, and oh, nothing happened, the surgery went fine, and you never gained your full neuro status. So that's my biggest scare. So I'm really happy to see now with conscious sedation, where you're awake, you're not intubated, but they're doing a procedure on you. How do they know that you're being ventilated okay? So just putting you on a nasal cannula, getting a good O2 stat, that doesn't tell you the whole picture. Having exhaled CO2 being monitored, and that starts rising, so they've got your normal while you're awake, and they sedate you. And if that CO2 starts going up too high, that means you're not breathing. And they need to wake you up or stop the sedation and let you breathe a little bit more. So very important for conscious sedation. And then on mechanically ventilated patients, it's usually a continuous monitoring. cardiac arrest, no blood flow, we talked about that. You also get a 0 reading if there's a disconnect, or if the endo tube comes out of the trachea, it will show a 0. That sounds like a really good test question. Doesn't it?
I think it does too.
So you're monitoring your patient on mechanical ventilation and you're using continuous end-tidal CO2 monitoring. Suddenly, the monitor reads 0. This will indicate
It's connected.
patients in bronchospasm. No, I hope you don't pick 1, 2, 3, and 4, because it could be, what if it says bronchospasm? Would you pick that?
No.
Patient is anxious? Would you pick that one? No. Okay. So either cardiac arrest or disconnect, no blood flow, or tube out of trachea.
It's too funny.
And then if the CO2 readings are climbing, you're 35, now they're 40, and now they're 45, what's wrong with your patient? You need to switch out the end-tidal adapter, it's wet. Or the patient is hypoventilating. All of the above. Would you pick all of the above? The CO2s went from 35 to 40 to 45. Does that mean the monitor or the adapter got wet? Or does that mean that the patient's hypoventilating and now we're not getting rid of their CO2?
Hyperventilating, so 2 only.
Yes, 2 only. All right.
So since we didn't get to the Hackerton,
Yeah, so now I need to alter the test for next week.
okay, so that'll be.
I think I might just delay the test because
We would have 3 boxes out.